Welcome. In this video, we will take a look at a second example with our trigonometric identities. Again, in this section, we are looking to express each of these problems as a single trigonometric function. So let's consider some of our identities that we could use for number 2. So I have the secant x minus the cosine x, and then divide by tangent of x. So let's start by getting this in terms of sines and cosines and then working it from there. So the secant function we know is going to be 1 over the cosine of x minus, we already have cosine of x, really over 1, we can write it as a fraction. And then we'll divide all that by the tangent function, which we know is sine x over cosine x. Okay, so let's consider now thinking about getting our numerator cleaned up a little bit. We are adding some fractions here. So in a very similar sense, we can go and consider getting a common denominator of cosine in this numerator portion. So I can multiply here by cosine of x and cosine of x to get a common denominator. So if I rewrite this, I'll have 1 minus, we'll have a cosine squared x in the numerator, all over, we'll have a common denominator here of just cosine x. So that will be my numerator expression, and then I'll have the sine of x over the cosine of x for the denominator. Again, we can make a adjustment here with flipping and multiplying these two fractions. So one way I can rewrite this is 1 minus cosine squared x and then times the reciprocal of my denominator, and we notice there's a couple things we could do using the Pythagorean theorem identity first. We can notice that 1 minus cosine squared, this is actually going to be the sine squared x. And I can look to cancel out my cosines to 1, and then I can cancel out my sine functions, and so I'll be left with sine of x. So just sine of x for number 2. So again, we used the reciprocal functions in this. We used adding fractions, and we considered multiplying by reciprocals and the Pythagorean theorem identity. So a lot went into this reduction into our final answer of sine of x. So let's take a look at number 3 as well. In number 3, again, we want to work this down to a single function. So I'll start with the tangent of t. We have a cosine of negative t, and then plus a tangent of negative t. So let's just remind ourselves, come back to our identities for the odd and even functions. We'll notice that the cosine function we said before here is an even function. So we have a nice identity to work with there. And our cosine, or our tangent function, is the odd function. So the tangent we know is odd. So tangent of negative x, or negative t for that matter, will be negative tangent of x or t. So let's rework this with those in mind. The tangent of t I'll leave to start. The cosine of negative t is just going to be cosine of t. And then the tangent of negative t we know is going to turn to a negative tangent t based on those odd and even identities. So this one actually simplifies quite quickly. We have tangent of t minus tangent of t. Those will cancel to 0, and we'll just be left with cosine of t. And that will be the completion for this problem. In the next video, we'll take a look at some more identities. Look forward to seeing you in the next part.